we're going to take a look at what are called coordinate proofs. Now, coordinate proofs aren't all that difficult to deal with. It's more or less using the information that you have, that you can see, draw out, and identify. And the nice thing about this is, this idea, you can put the figure on there any place you want. Granted, there are bad places to put it and better places to put it, but as long as they're placed on there, you usually do not have a problem. So, let's try this. I want to put this triangle on a coordinate plane. Well, first thing I need is my coordinate plane. And now I need a triangle that has a base of 4 units and a height of 3. So I would probably want to go and do something like this. It says a base of 4. 1, 2, 3, 4. Height of 3. 1, 2, 3. So, did I create my triangle? Did I put it in the correct place? Well, could have I, that is not what I wanted it to do. Actually, I just need to get rid of that for a minute or two, put that down there. That's what I should have done to begin with, but that was okay. So, got my triangle. By the way, could have I put my triangle like this if I wanted to? Sure, it's on the grid. I could put it back down here, you know, where I had it to begin with. I could have set it over here like this. I suppose if I wanted to, I could have even drawn it out like that and put it there, or I could have put it there like that. The point being, it really doesn't matter where it goes, just as long as it has the properties that are described. So, I'm going to give you a moment here, and I want you to go through and do this. All right, here we go. Now, I'm supposed to place a right triangle with a leg length of 2 and 6 on the coordinate plane so that its legs are on the x-axis and the y-axis. So, first thing I'd start out to do, give myself my x and y axis. Let's see, I probably want to put this down here a little bit further. Generally speaking, if they give you an order, 2 and 6, and then they say x-axis and y-axis, they generally want you to continue that pattern. So that means that on the x-axis, they would want it to be 2 units. So I've got my 2 units. Y-axis should be 6. 1, 2, 3, 5, 6 is right there. And so there. Is my right triangle perfect? No. But is it drawn out the way it's supposed to be? Yes. Now, label the vertices. Well, obviously, this is 0, 0 down here, correct? This one here would end up being 2, 0. This one up here would be 0, 6. Okay. And this is one of the nice things about being able to use it on top of a coordinate grid like this. You're able to go and identify and justify measurements a lot easier. So, I want to use a coordinate proof to show that this is an isosceles triangle. Well, what does it mean to be an isosceles triangle? Well, last I checked, isosceles triangles had to have two sides that were the same, correct? So if I look at this, I see that it appears to me that HJ and IJ would probably be the same, correct? Does that look like it? So could I do this? Well, let's see. 1, 2, 1, 2, 3. Could I say that HJ squared is equal to 2 squared plus 3 squared? Is that legal? Yes or no? Okay. 1, 2, 1, 2, 3. Could I say that IJ squared is equal to 2 squared plus 3 squared? Is that legal? Could I then, well, since 2 squared plus 3 squared and 2 squared plus 3 squared is the same thing, could I say that HJ squared is equal to IJ squared? Would that lead me to say that HJ would be congruent to IJ? Do I have an isosceles triangle if that is the case? Yeah. The answer is yes. So what I want you, I'm going to give you a couple of minutes here, and I want you to go through and do this, but I want you to use a different method than what I just did. See if there's something else that you can use. All right. So if I look at the situation, Colton, what could I use to figure out if this is going to be an isosceles triangle? What? Measure the sides. So what would I have to use in order to find the measures of the sides? What? The grid is on. Well, yeah, but okay. So Gavin, he wants me to use the grid. So if I'm going to use the grid, what would I use? Hmm? Well, yeah, but what property? What do I need to know about the legs in order to do anything? Why don't you know? Well, we just talked about a problem where we had to find that the length was the same. How do I find the length of it? Well, what other way is there besides making a right triangle out of it? What other way is there? That's kind of what we do when we make it into a right triangle. Well, is there a formula that we can use? Distance formula, most definitely. So I suppose then I could say that, okay, I got JK, so that JK is going to be equal to the square root of, something squared plus something squared. Of course, these are subtracting. So the x coordinates, so if I take it in J and K, that would be 1, 0 and 1 minus 0, which means that it's going to be the square root of 1 minus 0 is 1 squared is 1, plus 1 over here, which is going to be the square root of 2. Distance formula, most definitely. When you got coordinates, it really comes in handy. So what about LK? Whoops, wrong way. Could I do the same exact thing? Well, got that. So I got 1 and 2 there, so it's going to be 1 minus 2 there, and 1 minus 0. So 1 minus 2 is negative 1, negative 1 squared is 1. 1 minus 0 is 1, 1 squared is 1, square root of 2. So if jk is equal to the square root of 2 and lk is equal to the square root of 2, is jk equal to kl? Have I proved that this is an isosceles triangle? Yeah. Distance formula, coordinates, always is a handy thing to have. So, what about this idea? I want to go and put these down on coordinate grids and label things. What does that look like? Well, let's see. Let's try it with a square here first. So, square has side length 8. Does that matter what I do? Absolutely not. As long as I draw out a square, we're good. Now, this side length here is supposed to be A. Okay. So, what are the ordered pairs going to be? Well, that's going to be 0, 0. Now, again, I try and use the origin as often as I can. Since this distance here is A, this one here would end up being A, 0. This one over here is going to actually be A, A. And this one over here turns out to be 0, A. I don't know what A is. I don't care what A is. All I need to know is if placing it like this, I would have it. Now, could I go through and actually draw a square out, putting it in the origin in the center? Yes, but it makes it for a more complicated system if I do it that way. So let's try another one. Parallelogram. Well, if I'm going to do a parallelogram, I want to draw something that is going to be a parallelogram. Now, I realize a square is a parallelogram, a rectangle is a parallelogram, but if we are going to draw a parallelogram, draw a parallelogram. So, here's my parallelogram. Is that a parallelogram? I say it is, so therefore it is, correct? Now, it said that one side had to be length C. So if this is length C here, is this length C up there? Okay, so far so good. Now again, I've used 0, 0 right there. This coordinate here is going to be C, 0. After all, that is C long, correct? Now, I need to know something else. I need to know what the height is going to be. Could I just say that the height is B? So if I wanted to, I could call this one C, B, correct? I have no idea what B is. I just know that it's going to be B. Now, this one over here is going to be a wee bit trickier. Oh, is this actually going to be C as well? But C is down here, isn't it? So if C is here and C is up there, is that possible to do that? You shake your head yes, but this is further away from the y-axis than this one is. How much further away from the y-axis is it? 1 unit, right? So, but I don't know what that distance is. So, because it's one more this way, could I say it's C plus A, comma B? Would that work? Would it? Because I moved it over one unit of whatever. I have no idea what it is. I just moved it over that far. Is it legal? I have no idea what it is. But whatever it is going to be perfectly fine. And that sets this coordinate up right here real simple. Because how far over from the y-axis is it? Is it the same distance that I pushed this over here? So this could be A, comma, B. But it's having that ability to go and look at it and say, okay, how much further should I move this? Where is it at? How do I describe the distances? It takes a little practice and takes a little time to go through and do. So let's try another one here. I am supposed to go through and assign coordinates for the vertices and an isosceles triangle with a height of 4 from the vertex. Well, if I'm going to do a height of 4 from the vertex, I want to make this thing real simple and easy, and I'm going to go 1, 2, 3, 4. So there's my 4. Okay, 4 units high, and I have to have an isosceles triangle, so the distance here, so if I put this here, I put that there. Is this the same length as what this is? Most definitely. And there's the base. So now I don't know how far this is, do I? But if I say that this distance here is A, this distance here is A, this turns into negative A comma 0, right? Because it's that distance to the left. This one here would be A comma 0 because it's A units to the right. And this one up on top here would be what? Well, that's simple. That would end up being 0 comma 4. Now, mind you, we could put this other places, but it will make identifying the coordinates a little trickier, like we had over here with the parallelogram. So, I'm going to give you a few moments, and I want you to go through and do this one. Alrighty, here we go. Place a right triangle with legs of length A and B on the coordinate plane labeled the vertices with their coordinates. Now, I want to do this as simply as I can. So, my vertices. I am going to call this, I'll call it A. Doesn't matter. Now, the only thing is, can B be the same distance as A? No, because they're supposed to be different. If it said a right triangle with leg lengths of A and A, then that would have said that. So if I want to, I can go and make this one here B. Would that work? Does that fit the description? And it does. So when I complete the triangle off here, this coordinate over here would end up being A comma 0. This coordinate here is going to be 0 comma B. And this coordinate here obviously is 0 comma 0. Now, could have you placed it on there differently? Yes. This would be my recommendation. Because we always want to try and make this as easy as we possibly can. So, what we're going to do here is take a look at writing a coordinate proof. I want to prove the diagonals of a square are perpendicular to one another. So, let's start off with coordinate plane. Now, you'll notice how I kind of draw these things. I tend to want to work in the first quadrant, simply because everything is positive there. So let's go through and make myself my square. Let's see, I'm going to make it this way, this way. And don't make things too small because you want to give yourself some room to be able to draw and see what's going on with it. Now it said the diagonals are going to be perpendicular to each other. Let's see, the coordinates would be handy right now. So this would end up being 0, 0. Do I have a distance here? Now, would I want to go and say, hey, this is 4 units? Could, but I don't necessarily know what that means. So I would be better off calling this here a comma 0. Okay, because I want a proof, I want to make it so that it's going to work with any length side. I don't want to use a number. So this would be a comma a, and this one over here would be 0 comma a. Now, I want to go and demonstrate that these are going to be perpendicular. What would I have to know about the diagonals? And I want somebody to provide me with that information. What is it that I need to know? Yeah, that's what I want to find out. I want to find out that they're perpendicular to each other. But what can I do? What does that mean? How do I identify that they are going to be perpendicular to each other? What are the ways that I can do that? Are there ways that I can do that? Well, it was a square, so yes, that means that this has to be 90 degrees here, 90 degrees there. But I really don't see a nice, easy way of coming up with that because the diagonals would bisect. But that might tell me that they're perpendicular to each other. But I'd have to make sure that this here was a 90 degree, and that was, it's possible. But there's another way of doing it that's by far quicker and easier when you have coordinates, especially. What would it be? I would recommend that you sit there and look, think, and search, try and figure it out. Slope. Well, no, you don't need to worry about the y is equal to mx plus b bit, but you need to be concerned about the slope. We've talked, you're right, that is, but there's a specific thing that we've talked about already when it comes to slopes. If two lines are perpendicular to each other, their slopes are opposite and reciprocals. So if I could show that this one here, we'll call him red line, if the red diagonal has a perpendicular slope to the green line, would they be perpendicular? Okay, they got to be opposite reciprocals. So let's start off with red and not with green. So if I start off with the red line, its coordinates, now remember, slope, y2 minus y1 over x2 minus x1. So if I do this, it would be a minus 0 over a minus 0, which is equal to a over a, which could be equal to 1. What about the green line? Well, for green, always helps you put enough letters in there. That could be, let's call this one 1 and call that one 2. So that would be a minus 0 over, 0 minus a. This turns out to be a over negative a, which would be equal to negative 1. Now, sometimes you don't see that they're reciprocals of each other. But if they are opposite reciprocals of each other, when you multiply them together, you get -1. Again, we've talked about this. So if I go and take 1 and multiply it by -1, it equals -1. So the slopes of those two lines multiplied together equal -1. Therefore, they are perpendicular. I realize that there are a boatload of rules and definitions that you guys must learn, but you must learn them. So, what I want you to do is I want you to determine that this is going to be a parallelogram. I'll give you a couple of minutes to sit here and think about it and identify what it is that you need to make sure that things are parallel. Okay. There are actually a couple of ways that we could proceed with this. If I want to know that things are parallel, what do I need to know? Or what is one of the things that I should know or could know? What? Slope. So if I have parallel lines, they have the same exact slope, correct? Right? That would be a way of dealing with this. Another way of dealing with this is the distance between the lines is always consistent, correct? If I've got parallel lines, the distance must be the same. So I'm sitting on a coordinate grid. What is the distance between U to V? 1, 2, 3, 4, 5, 6. So the distance up here is 6. Distance down here is 6. So does that imply then, or prove to us, that UT and VW are parallel? Okay. I use the coordinate plane to go through and do this. Okay. If these two values would have been different, then it would not have worked, right? Now, what about between top and bottom? Well, if I count it out here, that's 1, 2, 3, 4, 5, 6. If I count down here, 1, 2, 3, 4, what's that? 1, 2, 3, 4, 5. Always helps if I learn how to count, right? 1, 2, 3, 4, 5. Yep, that's what I thought. So this distance here is 5. This distance here is 5. If that is the case, then this must be a parallelogram, correct? Because opposite sides are the same distance apart at two different points. Simple and easy, right? Now, if you want to, we could have done the slope, correct? Now, the slope probably would have been a little bit more accurate, if you want, not to say accurate, but show a little bit more precision. Generally, when we look at the distance between things, we want to go through and identify it on a perpendicular line. Now, UV and TW are not perpendicular to those two, but they do still serve the same purpose. So, oops, try this. Contractor's been hired to build a swimming pool with a small wading pool beside it. Contractor always draws a diagram of what he plans to build and overlays a coordinate grid on this, showing that the wading pool has a surface area that is 1/8 the size of the larger pool surface. Okay. Now, I have all this stuff here. Because it's sitting on a coordinate grid, I can go and say that every one of these blocks is 1 unit, correct? So that means 1, 2, 3, 4, 5, 6. So if that's 6, 1, 2, 3, that's 3. So the area on this thing is going to be 6 times 3, which is 18 units, correct? Okay. Now, what about the triangle? Triangle has a base of 1, 2, 3, height of 2 divided by 2, because it's base times height divided by 2, correct? So this has 3. Now it says, show that the wading pool has a surface area that is 1/8 the size of a larger pool surface. So here we go. If everything is correct on here, I could just multiply, whoops, sorry. I could multiply 18 by what? No, 1/8. Because this is supposed to be 1/8 of that. Now, does that look like it's going to work out? Because that was 1, 2, 3, 4, 5, 6. This is 1, 2, 3. I end up with 18/8, which would work out to be, let's see, that would be 9 over 4. And what's 9 over 4 equal to? Well, yeah, that would end up being equal to 2 and 1/4. So, is that true? Does the contractor have the wading pool the correct size? Does he? What would I need it to be 1/8? Well, I would need it to be 2 and 1/4. Did I get 2 and 1/4 there? No, I got 3. So, did he get it right? No, he did not. Now, would have it been better for me to go through and use the information that he had? Would have it? Let's see if that would have helped. So, how would I figure out the area of the pool? Well, that would just simply be, this is C, that's D, that would have been C multiplied by D, or just simply CD. What's this distance here? Let's see, this coordinate here is 1, 2, 3. Well, that would end up being C over 2 multiplied by the height, which is going to be negative D. Well, I'm not going to put negative in there because that's looking at just distance, times D over 2 multiplied by what? Or divided by 2, correct? Because that's the base, C divided by 2, multiplied by the height of that, correct? So if I multiply this together, what I end up with is going to be C D over 4 divided by 2. 2 over 1 multiplied by the reciprocal, which is 1 over 2. So that means it's CD over 8. So does that show it? Does that show that this is 1/8 of what this is? Because this is C times D, this is C times D divided by 8. Now my question is, why in the world didn't the numbers work properly? What would cause that? What would have caused the numbers to have gone the wrong way? Oh, true. Can I always assume that the length and width are supposed to be the same? And in this case, you should be able to. The only thing that I can assume here is that the drawing is incorrect. Because I can see that this definitely is 3. This definitely is 1, 2, 3, 4, 5, 6. That should be 3 to 6. That is 3. This is 2. Okay. So Assignment is due at the end of class tomorrow. My recommendation to you is do the easy problems tonight. Bring the hard ones tomorrow.